All right, we're going to go over section 2.4, and this is our proof section, or algebraic proof section. And so I'm just going to go over these properties real quick, and I'm going to show you how to use these. Basically, we're going to make logical or mathematical arguments. These are the same kind of arguments that you'd have to do in a court case, both civil and criminal. And believe it or not, most cases that lawyers deal with never go to trial. They're all on paper. A lot of times, if you can provide enough evidence to the other side for whatever it is, the other side doesn't want to fight it because you can't fight fact or truth or evidence. For an example, you have two people arguing, I'm not going to pay the bill. The other person says you are going to pay the bill. One person produces a contract where it says the other person agrees to pay the bill. It's hard to fight that, right? The only way you can fight that is if the first person didn't provide the service. So that's how cases work. We're not going to deal with law cases like that, but we're basically doing the same logic. And we're going to start with algebra, and then in chapter 3 we're going to move on to geometry arguments. And then when we get good, we'll be done with it. And then we'll move on to different topics, because that's the nice thing about geometry is if you don't like what we're doing right now, just wait a chapter and we'll do something different. Then you might like that better. That's not how algebra works. Algebra, we just basically keep doing the same thing over and over and adding stuff, right? Okay, we keep adding stuff, but we kind of change the feel of every chapter because it's just a little bit different. So addition, property of equality. This is what you do all the time when you solve algebra. You just might not have known that's what it's called. Okay, so I just call it the add property of equality, and basically you have it copied down. It's on these pages. There's not a lot to explain about that, but basically addition property, you add something to both sides. Subtraction, you subtract something to both sides. Multiplication, you multiply something to both sides. And division, you divide something to both sides. The only difference, and I'm going to write this because this is the important part. If A equals B, then I'm dividing both sides by C.
We can't see that.
You can't see that because I'm too high? All right, thank you. C cannot equal 0. What happens if Z equals 0? Well, sure, it's wrong. But can you divide by 0?
No.
Okay.
Syntax error.
You're going to get a syntax error in your calculator. Okay, these you've done. These might be a little bit different. We're going to use reflexive a lot, actually. And it doesn't make very much sense algebraically speaking, but you'll be okay. Basically, it states that A equals itself. Okay, here's where it will come in handy. We might have a triangle here and a triangle here. I'll call this AB. Both triangles share this line, right? And so we will use this for the reflexive property where two things share one thing. And we will have to establish that those do equal each other for a reason. Leave this one alone. Just know that it just means that it equals itself. Symmetric property. We do this all the time without even thinking. Okay? Basically, if we get an algebra answer like this, we just automatically switch it around like this. That's what the symmetric property is. So for the purposes of our proofs, we're going to have to do the symmetric property correctly. When we get back to just doing algebra, you're going to do that, and that's okay. Transitive property and substitution property can be a little bit confusing. The transitive property is basically the law syllogism. That is A equals B, B equals C, A equals C. Okay, it goes in that order. That's how the transitive property is set up. A lot of times you use the transitive property for more complicated situations. The substitution property a lot of times is for less complicated situations, like, and I'll just give you an example, like A equals 8, A plus B equals 14, I'm going to substitute 8 plus B equals 14. That's more of a substitution property. It doesn't really go in any order. It's more of a simple situation. But a lot of times you'll have something like A equals B, if you can still see it. And then you'll get let me make sure I don't do it wrong. Was that even in your book?
Substitution,
Oh, it's in its first section. And then you just do A equals B, and so in a problem like A plus B equals C, you would do A plus A equals C. So you see how it doesn't go in the same order as this? So that's kind of how you use it. If you mess this up, I'm not super worried about it. But just know the transit property is going to go in this order. And if you want to use it, try to do it in that A, B, B, C, A, C. And distributed property, you know this. All right. Abbreviations. Substitution, I usually do sub. Property, I always want to say property because we need to know what kind of rule it is. Substitute and transitive, symmetric property. Reflects. Those are easy. The only really hard ones that I think is substitution. If you're going to abbreviate substitution and subtraction, you got to have a difference. So usually I do subtraction like this and substitution like this. That way we don't have the same abbreviation. Okay, so if you abbreviate, do that. It is not my job to make you just write a whole bunch of stuff. It's my job to make you understand what you are doing. Okay, that being said, we're going to start with a proof for fun, and then we'll get to one that is more like what you're going to do. Okay, so how a proof is going to work. In this class, there's many different kind of proofs. If you look up proof on the internet, there's a bunch of different kind of proofs. Some are more advanced than others. We, in this level, at the 9th grade level, we are going to do what's called a 2-column proof. And so a 2-column proof, that is ugly. And that ruler is just not straight. It is kind of bent up. It's old. Or make it work. This side's better. And that's still not very straight. I'll go back to that sheet of paper later. I can't blame the ruler on that one. I mean, I can, but that would be wrong. So a 2-column proof is going to have 2 columns. Okay? And so the information I'm going to need is I need to know what I'm going to prove. So here's what I'm going to prove. Let's get up there. So I'm going to prove to you that 2 equals 1. And to start a proof, I have to be given information. And I'm going to be given the information that A equals B. That's all I'm going to be given. Let's make it nice and simple. So in every proof, we're going to have a given, and that's the information we have, and then we have the proof. Okay, and this is how we're going to start all proofs forever to the end of time. Well, at least 2-column proofs, because other proofs are a little bit different. And this is, also goes true for a court case. You're going to start off with what's given. Okay, if you have a murder case that you're trying, what do you start with? You're going to start with the fact that someone's murdered, right? So if no one's murdered, you don't have a murder case. So you have to have, there's a murder that has been committed. So basically that's given. And so the first thing I'm going to write down is what is given. A equals B. And then I'm going to write, for my reasoning, is given. And I guess you don't have to write what I'm about to write, but this is basically going to be your statement. Go ahead and write it in your notes, but when you do your proof, you won't write this, but this side is the statement, and this side is the reason. And the reason has to be a law or a property or a definition or all kinds of stuff. All right, this proof is going to follow some logic, and you're going to help me figure out what allows me to do this. So the next thing I'm going to write here is this. A times A equals A times B. What property allows me to do that? Say it. Just a multiplication. I multiplied both sides by A, right? So I'm going to write the multi-property of equality, and that's usually how I write it, as an abbreviation. Some of you just write multi-property, that's fine. Okay, and then I'm just gonna make it neaten. I'm gonna neaten it up, because sometimes you just need to neaten it up. And when we do that, basically what we are doing is it's not a property, it is, it's just a simplification. I'm allowed to do arithmetic, right? A times A is A squared. That's just a simplification. So sometimes you have a messy thing and you're allowed to just simplify. And when you do that, you just write, I didn't do anything, I just simplified. Okay, so there's that. Now I'm going to do this. And let's see what property allows me to do this. A squared minus B squared equals AB minus B squared. What did I do? Just subtraction property? I subtracted B squared from both sides. Okay. So far, so good. Now, this is something that you did in Algebra 1, but you might have forgotten how to do it. You called it factoring. And I'm going to write the answer because this aspect will not be part of your homework. We're not going to deal with quadratics. You'll spend plenty of time next year or next class. Okay. And I squunched that in. So you remember factoring last year? It was like the opposite of FOIL. Okay. Basically what this is, we called it something fancy. All it is backwards distributed property. I don't know if they brought that up last year, but factoring is just doing the distributed property backwards. Of course, to do this to this is a little more complicated of a distributed property. That's when you did FOIL. But FOIL is just a distributed property. Okay, moving on. Now I'm going to do this, and let's see if you can figure out what property this one is. Okay, what property do we think this is? Okay, so you guys are good. Division property. Okay. And this is probably longer than any of the proofs you're going to have to do. But this one is a fun proof. I like it a lot. All right, I'm doing good so far. And so I'm going to simplify this up. And you might not have gotten to this. But basically, A minus B divided by A minus B, they cancel. They cancel just like factors do. And so then I end up with this. A plus B equals B. Okay, and this is just, again, simplification. Okay. And now I'm going to do this. B plus B equals B. Okay. What allowed me to change A into B? They're what? They are equal to each other, so what property allows me to change A to B?
Substitution.
There we go. Substitution property. Okay? Because the given said A equals B, that means I can change A into B at any time, right? And to change A into B, that is the substitution property. I am substituting B for A. Does that make sense? Okay. And now I'm going to write 2B equals B. And again, I'm allowed to simplify. And anytime I do that, I'm going to tell you that I'm just cleaning it up, simplifying it. We're allowed to do that because that's just arithmetic. B plus B equals 2B. So I'm going to simplify again. And I'm making the point that this is not the addition property. The addition property means to add something to both sides of the equal sign. I'm just doing straight up adding those together for that. And here's my last step. And I'm writing this excessively long. I can do it shorter. I could leave out the simplify steps, but I didn't want to confuse you. So I'm going to do the division property here. And then I'm going to simplify B divided by B, that cancels, so that leaves me with 2. B divided by B, that's going to cancel, and that's going to be 1. And that's simplification. And I have just proven that 2 equals 1. Okay? So here's what I'm going to tell you. I did this correct. There is one thing that I did wrong on purpose, that because clearly 2 doesn't equal 1, does it? But I made a nice argument that it does, right? This is pretty. I have all these reasonings. To fight me, you're going to have to figure out where I made my mistake. So I used all my properties. Which property do you think that I used incorrectly? And I might have pointed out, yeah, what do you think?
Negative division plot or distributive plot.
The distributive?
Yeah.
No, I did the distributive one correctly.
Multiplication.
I didn't want to trick you on this distributive property because you might not remember it. I did this 100% correctly. The multiplication I did correctly. This one I did it correctly. Okay. This is the one I didn't do correctly right here. Okay. So I am allowed to divide by the same thing, but what am I not allowed to divide by? By 0, right? And so they equal to 0 because they're equal to each other. So essentially, A minus B, since A equals B, that's the same thing as saying A minus A. I wrote A minus B. That's the same thing as substituting to say B minus B or A minus B. What's that going to equal? I'm not allowed to divide by 0, and so that's what messes up the whole proof. So the point I'm being is that I can make this lovely, pretty argument, and you can poke holes in it by saying, nope, this is not the rule. This is not allowed. Okay? And that is the same thing in a real court case. They can lay down every single thing, and especially in a criminal court case, but if they find a little mistake like this, that could be the difference between guilty and innocent, right? Because in this country, you can't just be 95% guilty to be guilty. You have to be 100% guilty, right? So even if you have reasonable benefit of a doubt, and this definitely is reasonable benefit of doubt because that's not how it works, it messes up the whole thing. So, but like I said, this was just for fun to go through this. You're not going to have to do this one, but you are going to have to do this one. Okay? I don't know if that translates, but
Who is that?
he's my favorite student I've ever known. Billy Madison. Have you ever seen that movie? No? Okay. He's old. That's Adam Sandler. He's the smartest man alive, according to this meme. That's old. All right, so this is what our stuff is going to look like. So this looks like a regular algebra problem, yes? And then we're supposed to prove this. Okay, so let's go ahead and try to do this on our own. Of course, the easy part is this. 40 equals 2 parentheses 3x plus 11. And that's going to be given.
You want us to do this on a separate sheet of paper?
I want you to do this in your notes.
Okay.
I want to have a good example in your notes of how to actually do what you're going to be asked to do. And I know you know what to do solving it algebraically. What we need to be able to do at this point is also do the reasons. Okay? Yes?
What if the simplest way to prove it would just be to substitute 3 in for x, and then just solve the equation and see if it's correct?
You are correct, but then that won't get us to where we're actually going. Because what we are trying to do is not do an algebraic proof. We're trying to do a geometric proof where you couldn't actually do that technique. So I agree that the substitution test might be good, but we want to do this kind of proof, and so we're going to have to do it the other way. Because this is basically, you'd never do this in real life. This is just a gateway to the world of actual proofs. Does that make sense? But thank you for thinking, because that's probably how I would do it in real life, is like, let's see if it works. Because it either works or it doesn't, right? Okay, and this is what I'm expecting you to do. Like when I say show your work, if you already know how to show your work, this is not hard. What did I do?
I just showed you a copy.
Okay. Let's see, what next? And a lot of times I don't show the intermediate step, I just do this. And the reason why I don't show it is because you won't at the next level. This is what, 18? What did I do to both sides?
Minus 22. Or, yeah, minus.
Subtraction property. I mean, if you wanted to, and actually the way the book does it, because the book is trying to bridge what you did in Algebra 1 to what you're doing in geometry. I just know for a fact you didn't do it in Algebra 1, so it's not bridging anything. The book actually will, along with it, will say what you're doing is minus 22 to both sides. Okay, so when you look up the answers in the back of the book, that's what it will say. And it's trying to bridge the gap. We just don't do that in Algebra 1, so it's not going to help you. All right, next is what? It's 3, right? And that is division property, right? Not too bad, is it? And am I done? Does this match exactly? See, you guys are good. The symmetric property allows you to change the order. And so basically the symmetric property allows you to do the mirror image, right? And that's it. I proved it, didn't I? All right, that's what we're doing.